Okay, 3.5, day 2. In this video, you will see multiplying functions, you will see dividing functions, and you will also see evaluating expressions of functions given a graph. So, let's get right to it. First step, obviously, when I look at multiplying and dividing, you should be able to say to yourself pretty quickly, when I have f times g at x, well, I know that what that means is that I should simply multiply those two functions. I can take f of x times g of x. Okay, pretty straightforward. The tricky one comes when we talk about division. Well, obviously, f divided by g at x, I can split it up, take f of x divided by g of x. You should be having massive flashing red lights, white lights, green, whatever it is, going off in your head saying, okay, some anxiety that I have, well, I have a fraction there, I know the denominator can't be 0, so when I do division, I have to remember that g of x cannot equal 0. Whatever is in my denominator cannot equal 0. Okay, so be careful. That's going to be the tricky part about doing this. All right, let's get some practice. Take a look. I give you those two functions. I ask you to find the new function rule, which is h of x, which is saying take f times g. So let's do that. Take f of x times g of x. Well, how do I simplify that from here? Well, I think what I would do is distribute, and there is my new function rule. Letter B, to determine the domain of that function. Well, no square root, no denominator, therefore domain all rails. So then I can obviously figure out what is h at 2, what is h at 4. Obviously h at 2, I'm just going to take my function rule and plug in a 2 wherever I see an x, and then simplify that from there. H at 4, same deal. I'm going to plug that in wherever I see an x. Simplify that from there. Ta-da, 56. Alright, you should be saying, alright, got it. Fantastic, multiplying, no big deal. When we divide, though, here is why I've been stressing to you, make sure you are able to factor. Function rule for division. Alright. Looks like that numerator can be factored. Think about your thought process. Those steps that are on the board right by the calculators, you should be able to picture and visualize that entire sheet at this point. Step 1, factor anything out. Nope. Step 2, difference of squares. Nope. Perfect square trinomials. Nope. Step 3, factor when greater than 3 terms. Well, I'm going to stop there. There's not more than 3 terms, so I know I can't group them. That must mean I got to be able to break these down into 2 binomials. Notice that a is 1, so I'm saying to myself, I want 2 numbers that multiply to get this. Those same 2 numbers better add to get that. What are they? You better be able to say at this point they are -3 and +2. What can I do from here? Notice that what I can do from here is I can cross out that x minus 3. My new function rule is simply x plus 2. Alright, so you're like, okay, no big deal. I don't get it. That was, alright, a little bit difficult, but I'm not sure what's going on. Well, here is where I see everybody make their mistake. They want to focus their attention when finding the domain of h of x. Well, they're simply looking at h of x and saying, well, that's x plus 2. So I know to find the domain of that, well, there's no square root, there's no denominator, so my domain has got to be all reals. And I would cross that out and say, nope, you are dead wrong. Why is that dead wrong? I want you to think about that. Understand that when we talk about dividing functions, I know that this bad boy right here cannot equal 0. So what I'm going to do is, to find my domain, even though that canceled out, I have to be careful. I know that x can't be 3, or I can't even get to my new function rule. So think about what that looks like on the number line. Write your interval notation, and voila, there's your answer. So that is the tricky part about doing division, understanding that your denominator cannot equal 0. All right, so then letter C should be very, very easy. Can you find h at 0? Well, is 0 in the domain of this function? Obviously, 0 is in there, so what I'm going to do is just simply, all right, find h at 0, plug 0 into my function, which is that guy right there. 0 plus 2, I think I can handle that too. Okay. Division, that's the tricky part. We will get lots of practice on the division to make sure you have that before we keep going. All right, so then example 5, I think this is a good place to leave off today. Evaluate each expression given, a picture. This, very, very, very simple. Think about what letter A says. F plus G at -2. Well, think about the definition. I know I can take f at -2 plus g at -2. So, to find f at -2, what I'm doing is I'm going over to where -2 is on my x-axis. I'm asking myself, where is my red function? So f at -2, well, that's obviously +2. Do that same thing, g at -2. So now I'm looking at -2, where is my g function? Well, my black line is at +3. So 2 plus 3, voila, is equal to 5. Your turn. B, C, and D. Come on, you should be able to handle this without me doing any more. B, C, and D, try them on your own. Let me know what you get. Okay, because you're trying these on your own. Letter B, you should be saying g at 6 minus f at 6. G at 6 is 4. F at 6 is -1. You might need to look at my picture to do that. I apologize about the graph that you have. 4 minus a -1 is 5. G divided by f at 8, well, break it down. G at 8 is 6. F at 8 is -3. Divide them, voila, -2. Last one. F at 4, G at 4, multiply them, you get -15. So, in this video, multiplying, dividing functions, and evaluating functions given a picture, I think multiplying and evaluating the easy stuff, division, we're going to have to get some practice on that, which we will do in class in the very near future.